Hey, what's up, dudes? Alright, I'm going to fix that real quick. Okay, let's go ahead. Let's get started. I mean, honestly, we can just copy. I think it's faster to just do it like this. Just copy that. Paste that in. It's going to be 817. 320. Alright. Change the name. Alright, so let's get rid of that. Okay. So extensions are good. Let me set my timer, and we're gonna do 68 minutes, and we're gonna let's see, what did we do yesterday? So yesterday we did 2 hours. We changed the name of apply receive data to handle receive data, since we'll be handling more than just one function. But I think we're actually not going to use that function. We'll see. Began working on adding depopulate sent data storage function server and client, but realized we may not need it. That's what I was just saying. And then we had sidetracked into sectional review of server, added many to-do list items throughout the file while reviewing necessity of associated sections and specific lines of code. Yep, that's what we did. Okay, so we stopped at line 295 in server. Let's go over there and see what we got going on here. Alright, so that's where we stopped, and yeah, so mainly what we did is we set up all these different to-do things. I reviewed a bunch of different code sections, and we figured out a lot of things that can be fixed, and we're gonna trim this up big time. It's gonna be so clean, it's gonna be so nice when it's done, and I want to really get that finished. So I messed that up here. Yeah, so we're gonna knock this out. Hopefully we can get server done within, I would say, the next like 2 or 3 sessions. If I can get that done, I'll be happy. Streaming. Alright. So this is where we're at. What line? Right here. Okay, so the next thing we're going to do is we're going to review this entire section as determined to be unnecessary. After a moderate review, see things to do for more info. If determined unnecessary, delete the entire section. Yeah, so that's how we're going to do it. So review code associated with transfer lists, possibly unnecessary. Is that the section we're looking at? Yes. Right, okay, so we determined that for all 3 types of receive, well, we determined it could be removed. For resend requests, the receiving client thread would access the other threaded client's sent data storage zigged with a lock to resend that data directly. And that's true. So if they receive resend requests, they just send it back directly. They would just lock the dictionary. And they would lock that, they would have to use the other connection and lock it and send to it. or no, that they would not use the other conlock. Sorry. Yeah, so that's fine. Then we have receive verification, and like, just thinking, is this like gonna cause any performance hit? I don't really think it would, because we already have, like, we have to share the data at some point between threaded client, and that happens currently through the transfer list. But the transfer list, like, you just replace transfer list with the like storage dictionary or whatever. There's got to be, you know, there's gonna be a cross communication between the clients at some point, if you want to operate like that, you know, with multi-threads transferring to both threads. That's just the way it is. So yeah, it's like it's basically identical as for performance, I think. It may even be faster, because you're simply just you're not checking a transfer list. Like with the transfer list, you have to check it and stuff, right? So you could just say, by not having the transfer list at all and not even having to think about it or look at it, you save enough to make up for any extra hit where you know, like, the other client handles it instead. But I don't even think there's an extra hit, because that data would have to, at some point, that data is going to need to be grabbed or touched by the other client thread, if it's through the transfer list, or if it's contesting for, like, their storage dictionary, whatever. So and that's something I just realized. Well, what about whenever we send from client 1 to client 2 and 1 on the server side to the client side, and the storage dictionary only stores it once, to where once client 1 says that they received it, they remove it from the storage dictionary. But if client 2 for whatever reason doesn't get it, then you know, like, we would have removed it if one of them needs it resent. Does that make sense? So, like, does that mean we should probably send it twice, right? I mean, we should probably store it twice. Like, if we send to if we send to both clients from the server side to the client side, and then we remove it from our sent storage dict once we receive a verification from only one of the clients, then that means the other client could have not received it, and then it would still get deleted from the sent data storage dict, and that means we would not be able to fulfill the resend request, because that ID would not exist. So that does need to be added to things to do. That's actually like a bug, if it is the case. I'm pretty sure that would be a bug, because yeah, they, like, that's two separate connections, it's two sockets, two different data transfers. Obviously sometimes things happen or whatever, and if you only store it once but it gets sent to both, that's an issue. And I do tend to, like, repeat these issues and talk it over extensively, because I find that when you talk about it extensively the first time, you're way more likely to make the right decision, and the time spent talking about it is worth the time, because you're not having to go back and refactor it because you did it wrong, just because you wanted to go faster the first time. So let's see. we'll say review. Well, we'll say verify that we store 2x sent data storage dict entries on server side. Server side send. Yeah, well, send is implied. Alright, and we're going to do 8.17.25, and this is going to say realize that I currently, I believe we, I think we do. We transfer, or we only store data 1x per server side to client side send, and then remove from sent data storage dict upon reception of receive verification. This means that if the other client never received the data, then we wouldn't be able to fulfill their resend request. So need to add 2x entries to store this data. You need to add 2x entries to store in the sent data storage state. One for each client. Yeah, okay. And so that's got to be taken care of. But I would like to trim up first, so let's do that before we worry about this. So let's move this here. Where we at? Alright, let's go back here. So let's look at this transfer list section. So we get our transfer lock, we check the length of it, we copy it. It has to be a copy to avoid iteration disruption when removing elements during iteration. We release the lock, we iterate through the list, we grab the core data, and if it's a receive verification, we remove it from that dictionary. If the core data is a string, then the requested send ID is equal to, double check, that's for a resend request. We'll send them their data. Okay. And then we have new data equals pickle dumps. And then we create the header. Okay, that's fine. And then the send ID. Other kind of send also. Then we send them their requested data. If or we still send, or we get the send ID, which is at index 1, and then we add this to the receive data storage object, and we're going to get rid of that completely, I believe. Then we, with the transfer lock, we remove the data from the transfer list. And yeah, there's nothing necessarily wrong with this. It's just not necessary. There's no real reason to have it. It is kind of tidy, but I don't want to add an extra like 50 lines of code just because it makes it a little bit more tidy, you know? So we're gonna completely get rid of this entirely. It's just gonna be gone. Let me make sure I do this right. Start client. Let's See things to do, determine, delete. So we're gonna end up getting rid of this, and we're gonna copy this whole section, and then we're going to completely remove it. It's gone. Now we're gonna go over to old feature storage. We're gonna add it there, and it's probably messed up the indent because for whatever reason when you paste thing, I guess that's because the indent level it was at, so it pastes it at the same indent level. I mean that makes sense actually. I finally understand how that works. And this was removed from server, and the date is today, and we removed it and replaced with each client thread immediately handling the requested operation from inside that thread without passing to a transfer list. Less code and more efficient. It's just better. Alright, so let's close this out. So we have server. Let's see, what are we doing? We don't actually use depop here. That's okay. Go back to server. We don't need client open right now. Okay, so that section is gone. It's been deleted. So now we can add that to devlog. Completely removed the transfer list section from server pi to instead use to use a more direct method which handles inter-thread operations from the current thread without using a transfer list at all. Good. Alright, so let's go back over here and let's just keep going. Side code triggered the end of the game. Nope. Alright, let's go to things to do. Go to possibly recent. Alright, so we got rid of that. So we need to add in code to take care of this. Now we need to add code in the server to fulfill this requested data. So we would say add code associated with add code in server pi. So we're going to add code in server pi to what? What are we going to do? Well, we're going to handle inter-thread operations. And this is going to create code which replaces the now deleted transfer list system to handle resend requests, receive verification, change attribute list, intended for other client thread. The royal we. So that's got to be done. but we're going to do that after we're going to review this. Where is it here? Yeah, we're gonna knock this out real quick. Alright, so now we're in the receive section. And in this receive section, we use the con lock. We have our log here, process ID, client 1 or 2, and start receive section. Yep, nothing wrong with that. That's a good log. They say with con lock, since we don't use ready 1 here, couldn't we just change this line to leave index 1 empty? It would reduce processing time. Yeah, and we don't actually need it at all, so we can just leave it empty. There we go. This line uses con while miracle uses CLPy. Uses an end network socket. Whenever we create the network. While do it around the unique section. Yeah, this is like, that's an old note. Let me just triple check because I'm being a little lazy here. This line uses con and server by, while the mirror client pi uses an end network socket. Whenever we create the identical function form of the main while loop to be used in both files, this must be accounted for. The best solution would probably be to pass the different objects as an arg past function, since we would need these lines to be inside. Yeah, this is talking about we're going to create a function that was identical, basically, one for the server and then one for the client, containing like all this code, because it's basically the same stuff for the data transfer, but it's not identical enough. We're not doing that anymore. So with conlock, maybe it would have been beneficial for us to do that, but I don't know. There's some differences between server and client, so it just didn't work. It never worked out. So we do with conlock ready is equal to select con, and that's for the receiving. That's the only one we need filled out. They say reception section. Oh, we can just call this receive section. What do we call it? Reception. Let's call it receive section, dude. All right. Handles receiving input data and preparing it for application. Okay. So if ready, and I don't think we need that div right there. So we get our header amount. So using con and then con lock, nothing wrong with that. So we check ready. If it's populated, we'll say if there's data to be ready, if there is data ready to be received. We don't need this. It's extra. All right, and then we get our header amount. And then here we go. This is what we were talking about yesterday. Review this entire section. I'm pretty sure we can get rid of 90% of this code, which references adders, etc. We don't actually need to assign all this to adders. Instead, just run inc data equals con receive header amount and continue. Yeah, we can run inc data equals con receive header amount and continue. Banana, coffee, smoothie, protein with a little bit of salt, oatmeal, protein, vanilla. So good, honestly. It's just like Smoothie King. It's a little melted. It's melted now, but still cold and good. Alright. So we don't actually need to assign this to adders, instead just run inc data. Yeah, we did all this for a save system we were gonna add, trying to be like extra clean and Pythonic, and it turned into just a mess. We're gonna get rid of this shit. If we discover a line can be deleted, we can review that attribute variable completely and remove all associated code, the entire attribute. Yeah, so let's do that. So if a client 1 or 2 and it's equal to 1, with conlock c1 inc data equals con receive. And this is saying the client side parameter of this adder would not need to be client specific, since it only operates on a single thread. They were only in terms of ink data, not C1 ink data. Yeah, and we're not worried about that because we're not like merging them together. So get it out of here. And we have ink data is equal to self C1 ink data, and this is something that we want to get rid of. We want it to be ink data equals con receive header amount done. All this extra shit we want out of here. So let's check out C1 ink data. And what is this? I know what it is. It was some dumb shit that I added, trying to be, just got way ahead of myself, and didn't even need it, dude. Preparing too much for the future is actually a thing. Don't prepare too much, right? It's like you don't want to buy a fucking like don't buy a generator if there's like a 1% chance of a 0.1% chance that maybe in the future you might need it. Like, buy a generator if there's like a 10% chance that you need it, you know? Like, it's just some things are not worth doing. You might think you're being extra prepared and whatever, but you just end up wasting time, causing yourself fucking problems. So C1 ink data is literally only used right here. That's it. That's all we do. We create it. We assign con receive to that adder. We then say ink data is equal to that. Then we do ink data reset. That's it. Nothing else. Nothing else, huh? That's mad work right there, dude. Yeah, let me just look at ink data real quick just to make sure, you know. Let's just, but I'm pretty sure. I already know what I was doing. I was trying hard though. I gotta give myself that. But trying hard don't mean results. We want results, right? Old features. Okay. Yep, that's it. It's out of here. So there we go. We're gonna get rid of that completely. Lovely. So let's go up here. I do like this techno mix. It's good. This is Jason Lewis. This dude's got some good. He doesn't do copyright, so like if you're he hasn't yet anyway. If you want music like while you're coding, programming, whatever, background music, it's pretty good. Alright, so ink data, self C1 ink data, let's just get rid of it completely. And I'll just get rid of both of them at the same time. So we're going to just do that project search on. And how do we see how I did that? It's faster just to click. Just click it. Alright. Let's see, what is this? And anything that is a data point in the project, like under that namespace, we usually put it in quotes, just so I know. I should probably have used asterisks, but I started using quotes, and that's just what I stuck with. Because using quotes will make you think it's a string like this, so it's probably better to use asterisk, plus it stands out better. So we'll probably switch to using asterisks instead. Alright, so those are gone. Yep. Make sure I deleted the right thing. I wasn't paying attention. C1 ink data. Yep, that's it. Alright, go back over here. And here we go. The purpose is to save the C1 in case of client DC, and we don't have that system implemented. And I'll add it when I add it, if I add it. If I do, I do. If I don't, I don't. But I'm like doing surgery. I don't want there to be junk when I'm doing surgery. I want it to be clean. You know? I want my workspace to be clean when I do my operation. Okay, so this is C1 ink data is equal to con receive. Let's change this. This is just gonna be bam, bam, and then this is gonna get copied and put right there. So now we have with conlock inc data equals con receive header amount. Great. And then C1 receive data. Well, that's a different one. Yeah, that's a different one. Okay. C1 inc data reset. Since it would be executed, we would reference that adder instead of this one. So we can go ahead and reset this one back to 9. Yeah, let's... Nope. Get it out of here. Simply would reference that adder instead of this one. Yeah, that's silly, dude. Silly shit I did. Alright. With conlock self C2. So this is the same little section, but for C2. So let's copy that. Get that there. Get rid of this comment here. Come right here. Get that out of there. And C2 inc data. Get that out of here. Alright. It's looking a lot cleaner already. Very clean. Very fast we did that, didn't we? And we don't even... this is dumb on its face. We don't need to do with conlock inc. We can just assign this regardless of client 1 or 2, because it's the same name spaces regardless. So we can actually get rid of this completely and get rid of this and put it up here, right here. So header amount with conlock, then we con receive, boom. And we may be able to get rid of this stuff as well. Okay, let's keep going here. This needs to be in quotes. Alright, that's it. Cool. That's done. So we got rid of C1 inc data. Make sure I get the name right. Yeah, server.c1 and C2 inc data. Alright, let's see what's the next thing we can get rid of. So this can get rid of that. Now we have this. Determine whether this adder is necessary. If it's just we got rid of it. That's the one we just got rid of. Well, actually, that's received data. It's okay. So C1 received data is equal to pickle loads inc data. So we can just cut that out as well, and we can just do we can just say receive data is equal to pickle loads ink data. Yeah, so this is gonna go bye-bye as well. So let's do C1 receive data. Actually, yeah, we'll do it like that. We'll do C1 receive data. And let's see what do we do with it. Okay, that's a different file here. Okay, there we go. C1 receive data. Network data purpose to save the received data for each other client in case of a DC. Get it out of here. Alright, server. C1 receive data. Pickle loads. Alright, so let's change this to be say receive data equals pickle loads ink data. We may be able to trim that even more. So receive data was equal to, it was C1 receive data equals pickle loads ink data, and then receive data equals C1 receive data. So we could just do receive data equals pickle loads ink data. And this is data will be in 1 of 3 formats. Put that right there. Sender ID. Okay. C2 receive data equals pickle loads, doesn't matter. Receive data equals C2 receive data, doesn't matter. And then we have the sender ID is equal to receive data at 0. C2 sender ID is equal to receive data at index 0. Yeah, and then we just say receive data equals 0. So this one, we can get rid of that one as well. Associates adder client. Alright, what's the next one? Oh, I feel like we didn't do everything here. Alright, there it is. C1 received data. And then we're gonna have C2 received data. Get rid of that. Keep going. All this extra shit. C1 received data. This is going by. That's it. Cool. Okay. And this was C2, C1 and C2 received data. C2 received data, 294. C1 and C2 received data. This is going to be Okay, what do we have here? Line 1 or 2 and is equal to 1. Below line review necessity of this adder. Yeah, so that's going to be C1 sender ID. So let's find that. Because this ends up just getting up the sender ID. So this is just the data. We don't need to store it like that. Yeah, we don't need to store like that at all. Do we? We damn sure don't. Oh, we damn sure fucking don't need to do that, do we? Alright, so let's find this. That's literally it. For eventual perfect save, yeah. Eventually, yeah, fuck all that. Eventually shit. It's either there or it ain't there. We add it when we need it. Review necessity of this adder. C1 send ID. Get that shit out of here. What's this? C1 sender ID. Done. Get it out. Alright, that means we can get rid of that. Ooh. And then make sure you get rid of the C2. So is that one gone? That one's gone. And then we have the C2 sender ID. Let's find that. That's the only place that one exists. That one don't even... Oh yeah, because we already did delete it from the top. There it goes. Bam. Look at this. Look at that, dude. We just deleted what? Like 50, 40 lines. A lot. A lot of lines gone. Great. And then that was C2 sender ID. C2 sender ID. So this is going to be C1 sender ID. C2 sender ID. Entirely, yep. Since we could just use the local variable received data instead, and then this one is going to be the local variable sender ID instead. Yep. Alright, and now go back over here. Let's see. So much better, man. Oh my god. So that's with conlock, that'll be in 1 of 3 formats, sender ID, blah blah blah. Okay, we already know this. And then the intended recipient only for receive verification resend request. Okay. So index 1 is going to be the send ID. I got it. Inc data is equal to con receive header amount. Okay. Stretch here. Oh shit. Okay. So now we have inc data is equal to con receive header amount, and this doesn't need to be inside the conlock because we're not using the con anymore. Then we say receive data is equal to pickle loads inc data, so this deserializes it. Deserializes the inc data. And honestly, I mean, that's fine. We should probably change the name to serialize inc data and then deserialize inc data. So let's do that below line. use this? Where do we use it? File short string. We don't use file name. Don't even need to do all that. Easy. Okay. We don't even need file short string. We don't need that shit. Don't need it. Don't need it. Don't need it. There we go. Okay. So now we have send data storage object equals that send data storage object, receive data storage object equals okay. So if client 1 or 2 and type of core data is equal to list, then sent received, and we're going to get rid of the received data storage object completely. Let me just quickly do a once over just to make sure we don't need it. Let me talk about it for just a second. So we have the received data storage object stores all received data. Why would we need it? Well, we would only need it if like what we need received data for. We need received data to apply the data. We're not saving it. We don't have the save system. We wouldn't use the storage object even if we did. Like we don't need to save it. We can save the currently received data. That's really all that matters. All the stuff that has been received gets applied within the while loop iteration, or should. Otherwise, we could save it under the namespace that it's currently handled under. So there's really, there's no reason for a received data storage object at all. So we're going to go ahead and get rid of that. Yep, we're going to get rid of it. So let's see. Add code to create the debug. What is this? Modify code and client by delete to fill the storage since being replaced. Let's see. Add code and start by to handle inner thread operation. Yeah, we do need to do that, but let's go back over here. So we have if client 1 or 2 n is equal to 1. Sleepy, dude. 15 more minutes. Let's hurry up and do this. Alright, so to receive data storage object, let's do Control Shift F on it, and it's gonna go completely away in server. We're not gonna touch client, we're only messing with server. So let's go over to server here. Save logic, maybe we'll check that out. So save logic, what is this for? Master save object dictionary. List of every single object that needs to be saved. That's for client, that's completely different, but we're gonna end up getting rid of that as well. But not right now. Anyway. Let's go ahead and server. So C1 to C1 receive data storage object. Let's see what we're doing. This is what we want to get rid of. Here we go. So we got C1 to 1, 1 to 2, 2 to 1, and 2 to 2. That's 4 lines. Review the necessity of the received data storage object. Pretty sure we don't really need it more. The purpose of them was for reconnect data restoration, but if we use the same persistent save system, we don't need to also store the data in the dictionary. True. Alright. Now this is gone, so see you later. Let me just read the comment just to triple check. Send ID. Val received data deserialized and formatted, blah blah blah. Some fourth element purpose to store received data specifically regarding which client was sent and which client it was sent from. And yeah, goodbye. Rest in peace. Salute. It's out of here. Alright, transfer list. Okay, yeah, we forgot to delete all the transfer list stuff. I thought we deleted all that, but we don't need that either. This is still in server, right? Yeah. Make sure we're staying in the right file. So transfer list is now, this is gone, right? No? I'll add it. Let me just do it like the right way here. To do below. Well, it's going to be 3 lines because we're about to delete one of them. We're going to say remove all associated code. Remove all transfer associated code since we decided to remove it. Yep. All right. So right here, the transfer received data storage dict that's not going to exist. All right. Next one. Transfer received storage dict is this one. Get rid of that. All right. So this is our signs proper sent and received, not the received one anymore. Alright, next we have received data storage dict. Let's knock that out here. It's going to be gone completely. Alright, received data storage dict here. And this would be the deserialized receive. We'll cross that bridge when we get to it. Send data storage dict, received data. C1, alright, get it out of here. This one, get it out of here as well. What is this? Sent data received. Alright. Received data storage dict at send ID is equal to received data. Saves the received data at send. Yep. Goodbye. Okay, now we have from the associated received storage dict. This section will only be utilized if when we implement the perfect save system. Currently we are opting for the periodic save point system, which is more simple and would roll back all the data changes made from this iteration of the receive section of the main while loop. This removes the tube from the associated change attribute list from the associated receive stage storage dict since it has been applied. Then check to see if all tubes have been applied. Okay, well at the very least this part is gone. We might be able to delete this entire section. Then check to see if all tubes have been applied from associated change. If so, removes key value pair from associated receive data storage dict. That part is no longer true. Okay, and so this is when we're applying data. We sender ID equals tube -1, sender ID tube -3. Okay. What's this? Sender ID equals tube -1 gets the ID for the data was received from. I have to do this for blue lines. Send ID is equal to tube -3. Proper received. This just assigns proper received, and that's gone. Oh my god. I'm getting a hard on from this, dude. Yes. Get that shit out of here, dude. Associated receive change attribute list. Proper received storage dict refers to sender ID. Okay. And alright, so we didn't need this, right? Like, yeah, this just is. Why is the associated receive change attribute list referring to the storage dictionary instead of the a second. Hold up. Like, we don't need this, right? Hold up. So we receive data. Let's zoom out here. I gotta look at this again. Make sure I'm not deleting something we need. I don't think we need it, like, I'm pretty sure, but if we need it for that, then we need it for that, right? As much as I love to get rid of stuff, some things you don't want to get rid of. All right, so if we receive, if we're ready to receive something, then we receive the data. We would deserialize it. Then we have sender ID, send ID core data. So at this point it becomes the deserialized received data. Then we extract the stuff from it. And then what do we do with it? Let's see, what do? We then say send data storage, so on and so forth, get the receive time, and then we assign the core data to C1 received change attribute list, which is ultimately received change attribute list. Okay. So, like, the way this works is we get the data, we grab it, we assign it to certain variables by extracting data from it. We assign it to, like, this core data in this case gets turned to the received change attribute list. Then we have the received cal tuple list. And what is this difference here between the received change attribute list and the received cal tuple list? Okay, because we add more data to the received cal tuple list. So then we say alright, all that shit. Okay, then we have if the core data is a list. What does this do? Removes fulfilled resend request. Okay. Sends out receive verification. Okay. It's section twice. So this sends out receive verification. Then we say else. And what did it do? It added all the data to the receive cal tuple list. Receive cal tuple list. So we say the receive change attribute list, the one that we just extracted, we assign it to C1 or C2 receive change attribute list. Then we assign the cal tuple list to the received cal tuple list. Okay, I understand why we have that. That makes sense. Okay, sure. Then we go on to send out receive verification. Alright, and then this is for receive verification or resend request. If it's a receive verification, we delete this from the storage dig, and if it's a resend request, we resend them the data. Okay, fine then. Okay, all that stuff gets reset. We're gonna get to delete so much of this. I'm seeing it and I'm like, we're about to, this is all gonna get deleted. Not all of it, but like 50% of this is going away. It's gonna be great. I'm so excited, dude. Okay, if type core data is equal to list, because it was a nightmare. This file was a nightmare, straight up. Point blank period, the end, it was bad. If type core data is equal to list, okay, here we go. Now we're getting somewhere. Now we iterate through. See, and this is so scattered, man. We can clean this up. Like this, I know that there was a reason I did it the way I did it before, but you know, that's part of improving. I just see it could be way better. We're gonna fix it. So if the type of the core data is equal to list for tube and receive change attribute list, we append each thing from the receive change attribute list to the cow tube list, and we add that extra data. That's fine. Ideally, I would want to get rid of this received cow tube list, and we would just have the one change attribute list, and we would just modify the tuple itself and like replace it. You know what I mean? So instead of having a separate list, we would just have the one, and we would just tack on more data to it and replace it. It's like easier to keep track of. It makes more sense. It becomes confusing when you're passing all the hot potato shit. It becomes very confusing over time. So we want to get rid of that. Any hot potato bullshit, middlemen. No. It's not the way. Okay, then we check the length of the received cow tube list. If it's greater than 0, we sort it. That's great. We need to do that. And then now this is the application section where we apply the data. And let's just call this apply section, because application makes me think I'm applying for a job. But it's a data apply section. Or apply data section. Yeah. So we say receive data, and then we call it the apply data section. Alright. And then we check, we get our receive cow tube list. That's going to be changed to apply list for tube and receive, blah 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 blah, all this bullshit here. If the length of the receive tube is greater than 0. Okay, so if the receive cow tube list is populated, we transfer to the apply list. See, there's a lot of hot potato shit that goes on. We're gonna try to improve that to we're gonna try to improve this, and maybe just reduce it from 3 lists just to 1. And I'll add that to things to do real quick. So we're gonna say try to reduce from 3 lists to 1 for change attribute list, received cow tube list, and then apply list. Keep in mind necessity of what are you saying? Needing copies for deleting iterations, deleting data during iterations and all that though. And then be careful, very important. Yeah, this is like very sensitive. This is the main part of the game that transfers the data. Very important, and if you fuck it up even just a little bit, it becomes such a terrible nightmare to debug it, and when you're running it, that you could get lost in the labyrinth. Okay, so long story short, we have figured out what goes on here with this, and then we append to the apply list. Okay, I see now. Now we made it to the section that we were looking at initially. So if the receive cow tube list is populated, we create the apply list, iterate through the cow tube list. If the expect counter is matching, we append it to the apply list to be applied. If it's the right thing, then we iterate through the apply list. We go ahead and apply that data, and then we remove the data from the received cow tube list. And the received cow tube list does indeed So the receive cal tupless only removes data that has been applied, right? If the data doesn't get applied, it doesn't get removed. Now, does the receive cal tupless get like, does it retain the data that doesn't get applied for the next time? So the next time we roll around, it checks to see if ready, and if it is ready, we assign the received cal tupless equal to the C1 received cal tupless. Okay, so it's still the same object. Like, we're not reassigning it really. So we don't lose anything from the last iteration. And then we eventually end up let's see here. We end up eventually, where is it here? Data pickle dumps. No. Come on. Then we append to the received cal tupless. Right, so that's what I was looking for. So the received cal tupless is what holds all the data that gets received, and it persists through every while loop iteration, and the only time data gets removed from that list is when it gets applied. So after it gets applied, we remove it because, well, we don't need it anymore. We applied that data, we made the change. Now we can delete it from our, it's like a to-do list. It's what we need to apply, and then once it gets applied, it's gone. So from my understanding, then, this received storage dictionary doesn't actually, like, see, remove the tube, so, and then this removes the tube. Yeah, it doesn't it serves a parallel purpose. It's the same exact, it's doing the same exact thing that this does, but just under a different name. So it's extra. So let's see, we have sender ID, send ID, blah, and then we have the tube. So we're deleting. We have the associated receive change attribute list equals proper received data storage dictionary at the send ID add to. So if the associated receive change attribute list refers to the change attribute list in the received data tuple. Proper received data storage dig. So the proper received data storage dig doesn't exist anymore. That's why it's white. That was just a received storage dig. And then we remove it from the associated change attribute list. But we don't need that. We don't need the change attribute list gets transferred to the whatchamacallit, to the received cal tuple list. It becomes the change attribute list. Where is it? Received attribute list, right there it is. Is the core data. So we go from core data to eventually we do assign, there we go, to receive change attribute list equals the core data, and then we go from receive change attribute list to to receive cal tuple list. So it gets received as core data, gets called receive change attribute list, then we modify it slightly, and then it gets attached to the receive cal tuple list. The receive cal tuple list holds on to all that data. The received change attribute list is basically core data. So whenever the new iteration starts and we receive new data, it just goes away, and there's really no reason to hold on to it. It's just like it's a middleman. Once it goes from core data to receive cal tuple list, that's what really matters. receive cow tuplets is really what ends up applying the data and then deleting it once it gets applied. So ultimately, like, I think we can just delete this whole little section right here. It says this section will be utilized if we only have the periodic state system. Currently, we're opting for the periodic state point system. Yeah, blah blah blah. So we're gonna get rid of this. This checks to see if all tubes have been applied from the associated. Get rid of that. Now we have the sender to ID. I don't even see where we use that, actually. Yeah, I don't even see that. We might be able to get rid of that. I don't even see where we use that line. Gets the ID of the data. I have to do this before below line since it chops off this ID element. I don't even know if we need this though. Below line 817. I don't think we need this line. Review it. Yep. All right. So then the send ID, and same thing for the we'll say below 2 lines because I think we need these lines. Review them. All right. And then we have this tube. Reassign tube to conform to say prior to process. And so we have to do that because we're trying to remove it from the associated receive change attribute list, which was how it was originally. And the associated receive change attribute list is what? That's it. Is the proper receive data storage dict. So that's the only reason we have this tuple. So these 3 lines, actually, get rid of those probably. We'll review it though, just in case. Then we have associated receive attribute list. Anything with all those indexes, we want to triple check before we delete it, because some of that can be forgotten. It's ancient magic. Associated receive attribute list, that's gone. Goodbye. Associated receive attribute list removed. That's gone. Length of gone. 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 Boom. Love it. All right. There it went. It's out of there. Okay. We're going to go ahead and take a break. And we're going to say we removed the received data storage dict. Let me copy this real quick so I don't have to write it. Alright, go back over here. Put this in our devlog real quick. Actually, I gotta piss. I'll be right back. Alright, we're back. Let's go. Alright, so we completely removed that. Alright. That's done. Okay. Cool. And what else we got here? We're gonna get rid of so much of this still. It's more of it's going away. Yep, more of it's going away. Oh god, it's so great, dude. Oof, so good. Yes, 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 yes. Matter of fact, I'm getting rid of the to-do. It's gone. We'll add it again when we want to. Alright, we're gonna stop right here. And we're gonna keep chipping away at this until it is like clean. It is gonna be so clean, man. Immediate etly below to do task. We're gonna knock this shit out, bro. Alright, so this is line 276 in server. And so we'll just say stopped at line number 276 in server by. Alright. And the time is going to be 4:48. And that's an hour and 28, so what do you say, 1.5 hours. And alright, there we go. So let's review our devlog. Game testing, debugging, review, part 19. That's true. 8:17:25, 3:20 to 4:48. That's true. An hour and a half hours. That's true. Continue debugging, reviewing the game to test it. Specifically, remove transfer list section from server pi to instead use a more direct method, which handles inter-thread operations between the current thread without transfer list at all. Remove server C1 ink data, server C2 ink data entirely, since we could just use local variable ink data instead. More direct and simple. Completely remove server C1 receive data, C2 receive data entirely, since we could use local variable receive data instead. More direct and simple. Completely remove C1 sender ID, C2 sender ID, since we can just use local variable sender ID. More direct and simple. Completely remove the server receive data storage dict and receive data storage dict. Since we don't need to store receive data twice, already stored receive out list. Stop line 276 server 5. That's correct as well. And then stage commit push changes to remote repo and create a new local backup of the entire project. Alright, let's copy, go to terminal, root of the project directory. We are there. We're going to git branch, make sure we're on the right branch. We are. Git add stage, git commit -m, double quote space, devlog, 5 files change, 85 insertions, 168 deletions. So we net lost, we gained 85. We deleted 168, so, and lots of those are comments, and the to-do entry and the devlog is like 15 lines in and of itself, so you can go ahead and knock out about 30 of those lines, maybe even 40. So we added 45 lines, but we deleted 168, so we net lost like 120 lines, so we just cleaned up 120 lines of code. Great, awesome. We lost like 120 lines of code. That is massive. That's like a 15% decrease in the size of the server file. It's great. Now we're gonna get push up to the cloud. There it goes. It's gone. All right. Now we do create a local backup, because yeah, we need to do that. So let's go over here, and we're gonna go to programming projects. Backup, rename to today's date, which is going to be the 17th. Now we're going to enter into this. Now we're going to go back here. We're going to delete the old one. Paste in the new one. Text devlog. And review to make sure it's today's code, and it is. Alright, that's it, guys. Good session, great session, one of the best sessions I've had in a while. Really great, very fulfilling getting rid of this code. I'm gonna go eat a little bit. I'm gonna take a walk. I'm gonna we're gonna do maybe a little bit more today, maybe 30 more minutes, and we're just gonna continue doing what we're doing. We're gonna end up getting rid of this receive time, probably, I think, maybe, and more of these attribute stuff. We're gonna get rid of that as well. Probably about half of this code right here is gonna go away. Down here, I'm probably gonna end up getting rid of half of this right here. This is gonna go away because of the transfer. This is probably gonna go away as well, all this, and then so we're probably about to get rid of another, I'd say about 30 or 40 lines, and then more of this, maybe 45 lines ish. Yeah, so I'll say overall we're probably about to get rid of another 45 lines in this section, which is going to drastically reduce the size of our server file. It's now only 650 lines, and we're about to get it down to about 600. So that's going to be cool. Yeah, so, and it's just going to be easier to read, easier to debug. It's going to be better. It's going to be simpler. It's just all around massive improvement. Great. So I'll see you guys when I see you. All right. So if I come back, do you later. We'll do it again. If not,